wave lecture 6, right? So in this lecture, beta, basically, I'll discuss problem based on this, right? So students, for this condition, I hope you need to just revise all the formulas which you already learned, right? Entire alphabet. So today, beta, I'm going to just discuss problem based on tomorrow exam, or you can say based on ways uh, wave motion, right? So just wait with for 30 seconds so that I can say maximum candidate can join. Okay, it's been there, Srisham. Okay, fine. So now, beta, I'm going to start your numericals based for the study exam idea. Okay, so this students, I can say first numerical. My dear, this is the first numerical for tomorrow exam. Okay, beta, science will be note down questions with me. Uh, Sign you, sinus will be traveling traveling in the positive x direction, positive strings x direction has an amplitude of 50 centimeter, comma, student, wavelength wavelength 40 centimeter, and frequency ethos, the vertical displacement, the vertical displacement, the vertical displacement of of the medium at t is equals to 0 and x is equals to 0 is also 15 centimeter as shown in the figure, as shown in the figure, right, my dear? Okay, so come to the point, everyone, right? So have a look here. What's the diagram? So now I'm going to plot diagram here for these questions. This diagram will support you to understand these questions in a better way for further solution. So you can take this is x-axis, this is the y-axis. Graph starting from here basically, right? Okay, this distance mentioned here, how much amplitude? 50 centimeter. This amplitude beta mentioned this questions here, 0.15 meter. Okay, beta wavelength how much mentioned here? That is 40 centimeter. I hope it all of you remember as wavelength from what? 1. But from here to here. How much, my dear? But wavelength from here to here. Yeah. This is what, my dear? Means in yeah, 0.4 meter. Yes, beta. Have a look. Beta, this is 40 centimeter. This is 50 centimeter. Frequency beta means in here. Yes, beta. How much? 8 hertz. Right. What you need to find here? Yes, beta. Have a look of the questions. In the part A, my dear. Find, find, find the angular wave number. Find the angular wave number, angular frequency, angular student frequency, and speed of wave. And we tell you speed of wave. Again, I'm repeating what you need to find in part 1. Find the angular wave number, angular frequency, and speed of wave. Now, beta, have a look at part B. What you need to find. Determine. This is what, my dear. Determine the phase constant phi and right and right uh, write a general expression for the wave function. Yes, beta. So now this is the question. Once I'll read again. A sinusoidal wave traveling in the positive x direction has an amplitude 50 centimeter, but also mentioned in the graph. Wavelength is 40 centimeter and frequency and students frequency 8 hertz. The vertical displacement of the medium at t is equal to 0 and x is equal to 0 is also 15 centimeter. That is, you can see also beta 0.15 meter as shown in the figure. Find the angular wave number and frequency and speed of wave. Second question, determine the phase constant phi and write expression of the wave function. Easier, easy. You can do better. Literally, beta can easily can do these questions. Beta. So now I'm going to just solve these questions here. You will get to try this pattern of questions tomorrow. 100% the student you will get here. So in part A, bacha, we have to find angular wave number. What, my dear? Angular wave number. So beta, we have a choice. You can write it as k is equals to pi by lambda. You can also write omega by b. Both are correct only. So k bacha, angular wave number here, 2 pi bacha. And what's beta wavelength? That is 0.1, 0.4 bacha. So beta is decimal here. So you can say k is equals to 20 pi by 4. 4 pi is 20 here. So k beta can write what? 5 pi. K beta what you can say? This is what? It's 45 pi. Now bacha, this is, you can say bacha 40 radian per second. This is what you can say. Radian per meter. It's not second here. My bad. Radian beta per meter. What you can say, my dear? Radian per meter. It's what? Angular wave number. Second beta, what we can find? Periods. So you can say what's about time period here. Right. So beta, let us suppose here in part A, I'm calling part number 1. This is my dear part 2 here. We have to find this is what, my dear? Time period. It's nothing here. 1 upon frequency. Frequency mentioned in beta party? Yes. Here. Beta mentioned beta party. 8 hertz here. Right. So simply you can find beta party for time period. This is a very, I can say fundamental numerical beta. You will get here tomorrow. 110% beta party. So 1 by beta what we can say 8 here. Time period what? You can say in second. What my dear? You can say second. So which I can say here also we have to find what? I can say which wave number and the frequency. Yes, angular frequency bacha party in third. It's nothing but it's omega bacha. Angular frequency here, it's omega, which is equals to beta 2 pi f, right? So f beta we already found. F not found means already mentioned questions here. 2 pi into beta 8. So what is omega here will get? This is 16 pi beta g radian per second. 16 pi beta what you can say radian per second. Last beta we have to find what speed of wave. Speed of wave. Okay, this I'm now solving at part A only beta. So I can say beta part A we have what? I can say last part. Speed of wave. Right. So how can we find what's that part? I hope all of you remember here. As I said, V is equals to lambda f. V is equals to my idea lambda f here. So V by part lambda beta what? 0.4 and f बचा frequency है 8 बचा. So what will you get? 8 for the 32, 3.2. 8 for the 32 yeah. Okay, we can say 3.2 meter per second. 3.2 meter per second बच्चे body. Okay, what is last one was determine phase constant and write what expression बच्चा party for general expression for the phase constant. Okay, now बच्चा I'm going to solve your part number B. बच्चा in the questions here amplitude beta means here 15 centimeter or you can take 0.5 meter. What my dear? 0.15 meter. Okay. Bacha party. What's mentioned bacha party? That is here. Amplitude nothing here. It's you can say by beta in centimeter. You can write what? 50 centimeter. Right, my dear? Okay. Fine. Beta what question mentioned here? If x is equals to 0 at what you can say time is equals to 0. I hope all of you remember here general equation of a standing wave. Sorry, traveling wave बचा party. What means that particle motion positive x-axis here. So I hope all of you remember. This is y is equals to a sine of omega t minus kx plus y. Y is equals to a sine omega t minus kx plus y बचा party. Simple bit I can write further. So what's amplitude बचा party? What's amplitude here? That is beta. This is 5 here. So beta I can just put beta in this equation here x0 beta first speed you can put here t is equals to 0, right? If t 0 bacha party and x beta both are 0 0, so beta here you can put x also 0 bacha party t also 0. Let us suppose equation number a. So you will get bacha y is equals to what? Only a sine phi, so that we can get a phase difference. Y beta also 15 here for amplitude for 15 centimeter, but this is also here 15 bacha. So what we can sine phi cancel here. So sine phi what we can see 1 bacha body. So what about phi here? This is you can say phi bacha ji. Phi is equals to pi by 2 radian. Phi beta what you can say pi by 2 radian. It's true. Now bacha body. Finally we want to phase bacha. So you can write bacha directly. What is the equation here? I hope beta this value you can put over there only. Right. So finally bacha I'm going to write here expression of I can say traveling wave. So y is equals to a sine omega t minus kx plus phi. Right, my dear. A I only know. Right. Now beta I'll write in terms of centimeter only since this unit. So by which you can say 15 centimeter. Sine bacha omega what we found 16 pi. 16 pi radian per second. Now it's about it. Into beta, what you can say? T minus k beta, how much will you get here? In centimeter. Pi by 20. Pi by 20. This is radian per centimeter. Omega t minus kx plus pi beta. How much? Pi by 2. So this is should your answer for the questions. Yes, it's little look like lengthy because you are doing first time. Otherwise, it's a very standard common format of I can say for starting day. Very standard picture. So I can say just if you got delay, then you can just go and watch same picture here. It's highly required and highly appreciable, my dear. Good questions here. Now, Bacha Party, just move on next question here. Yes, Pitali, just move on next question. So, what's the next question, my dear? Uh, wave student or wave is described y is equals to 2.00 centimeter sine of kx minus omega t, where k is equals to 2.11 radian per meter. Omega beta you can take 3.62 radian per second. Right. Okay. Now which I can say x is in, my dear, x is in beta meter. X is in what you can say meters. Okay, and time is in seconds. And time is in seconds. Right. Determine determine the amplitude. Determine the amplitude, wavelength, frequency, speed of the wave. Yes, beta. So, beta, we have to find these parameters. Right. Again, here, it's not a repeated because of, I can see previous questions only. So, have a look here. Try to focus. Now, what I can say for the solution here. That is what you have to find amplitude, wavelength, frequency, and speed of wave. So, with the first here, you have to write equations here, given equation. In step one, you can write like this. In step one, my dear, that is y is equals to 2.00 centimeter sine of okay kx minus omega t. Remaining with the data k and omega, everything is mentioned in these questions. So you can write what's party by here 2 what's, and this is sine. Give it how much? 2.1. You can write 2.11 x minus 3.62 t. Right. Entire beta answer you can say here, this is in meter, this is in meter, and this is what is centimeter, and omega beta radians per second here. Okay, fine. Now beta listen carefully, student. What you have to find here? Amplitude. It's beta just equate here this equations from general equation of I can say traveling wave. Y is equals to beta a sine, right in same equation. This is what kx minus omega t. Simply what I can write here for amplitude. amplitude which is equals to 2 centimeter. This is the first answer for this question. What beta? Amplitude is equal to 2 centimeter. Yeah, next beta, we wish to find wavelength. Yes, beta. So we wish to find here, I can say that is what my dear wavelength. So it's nothing beta. You can say it's lambda, right? So K mentioned here, I hope you remember. This is what? 2 pi by lambda. K beta, what you can say? 2 pi by lambda. Lambda you can simply write here. 2 pi by K. K in meter beta means radian per meter here. How much? 2.1 meter. Simply beta. Lambda what? 2 pi beta upon 2.1. 2.11. What's your party? So this is your finally. You will get beta in meter. 2 I by 2.11 students. That is you will get in meter. It's my if it's a wavelength. It's a wavelength. That's how we have to find. You can see it. Okay. So because we have to find frequency. What's frequency, my dear? 1 by time period. 1 by time period. Or beta do one thing. Beta you can also write here. Omega is equals to 2 pi f. Beta just go from media points from here. Omega beta how much? 3.62. So simply we can find here. You can see from here only. Beta how much? Omega upon 2 pi. Hello student, how are you? Very happy to see you after a long time here. Frequency. Beta, this is omega here. Omega how much? 3.62. 3.62 upon beta 2 pi. Beta, it's hertz here. It's a hertz. Right, my dear? Oh, very good, very good. Beta, which competition, beta, and which exam are you preparing? Because it's used to, I observed, you join live session at physics one. So, in which class you are, my dear? It's beta frequency. Next beta, what I can say? That is speed of wave. Pretty easy to find. What, my dear? Last one, speed of wave. So simple beta. V is equal to lambda f. What, my dear? V is equal to lambda f. So lambda beta how much? Already we found 2 pi by 2.11. Beta frequency how much? 3.62 upon beta 2 pi cancel there. So we can say what this two decimal cancel 362 by 2.1 meter per second. It's a velocity of wave. It's a what of velocity of wave. Okay. So now what I can teach all our beta. I can say fundamental question students. These all are students. What I can say this is the fundamental questions. Okay. Fine beta. Let's move here. Next questions. So you can see what's our next question here. Let's do the next paper. Okay. So if please so I'm not right. Complete question we'll go through here data only. So let us suppose that I'm just taking displacement equations. Pi is equals to phi bacha is sine. This is t upon 0.04 minus beta g x upon 4. This is the condition bacha, right? So beta in this question you have to determine mm, what yes beta. Remember, find I can say beta maximum speed of particle. Find maximum speed of particle, right? It's again there's a very huge probability they can ask in tomorrow exam. Okay, so with the displacement equation here, I hope all of you remember. We will differentiate this equation with respect to time, keeping x constant. Then what will get velocity of particle? So now speed this we concentrate, my dear. Again, I'm repeating because in this equation, beta, in this equations, my dear, we have a two variable. One is time, one is x. So differentiate above equation, or you can say it's a partial differentiation, keeping x constant. Differentiate above equation with respect to time only. So this is what my dear, dava by dava t. This is 5 beta part. No, what's the chain rule? Beta, you can apply chain rule. So sine beta remains cos here. So this is no doubt, it's a cos beta part. Now, what is the coefficient of time will come out. So this is beta. First, you can write beta this function as it is. T upon what beta? 0.04 minus here x by 4 into beta 1 upon 0.04. Simple here. Very easy. So finally, you can write my dear. This is the velocity of particle here. So 5 upon 0.04. Just remove this one. You can say 500. Uh, this is my dear cos t upon 0.04 minus beta g x by 4. Right. So velocity of particle beta, you can write 500 by 4, which this is 125 cos t upon 0.04 minus x by 4. Right. But if you remember here, condition for maximum minima. Condition for maximum minimum, right? So cos beta, cos will change -1 to +1. This cos value beta will change -1 to +1. Right, my dear? So simply bacha, you can write here. This is boost one bacha for maximum velocity here. So simply you can write bacha. This is the velocity of particle is maximum. How much? 125 meter. So this is my dear answer for the questions. This is my dear answer of these questions. Right. Okay. So it's not tough at all, I can say. But it's highly required. Just keep in mind all basics point. Then you will get answer of these questions. Okay, beta. Let's move for the next question, my dear. Yes. This question I can say. Yes, I can frame next question, my dear. So this is what students. Next question. Y as a function of as usual. You can take. Yes, I'm taking simple. Yes, beta. Let us suppose I'm just giving you some data. You can apply 0.035 beta in meter only. Just keep in mind. Sine bacha g. This is 10 pi g minus 3 pi x. Beta, this is 10 pi t minus 3 pi x. You can take the initial phase angle. This is pi by 4. This is what, my dear? Pi by 4. Okay. So beta y is what I can say. Which as you can write for here. Yes, beta. Yes, my dear. So this is I can take it as an initial equation. Yes, fine. Uh, y is equals to 0.035 sine 10 pi t plus sorry minus 3 pi x plus beta what? Pi by 4 means initially here I'm considering I can say initial phase. Student, initially I'm considering what I can say initial phase. That is what pi by 4. But in this equation here, what you have to find? Remaining beta I can say y is in meter as I need to take beta. So first you have to find yes between speed and direction of traveling wave. Uh, find speed and beta direction of traveling wave. Yes, beta. Find speed in what direction of traveling wave. Beta, I'll do here one by one. So first here, in the classroom, I said this have a look for the questions. Uh, First here, right? Questions I'll frame first. What is the vertical position of an element of this string at student? What is the vertical position of an element of the string at we take t is equals to 0, comma x is equals to 0.1 meter. Question mark beta. In part C beta, what you need to find? In part C, what you need to find? That is, students, what is the wavelength and frequency of the wave? Student, what is the wavelength and frequency of the wave? Last bit of the part number D here. What is the maximum speed? Does it? What is the maximum transverse speed of an element of the string? Yes, yeah. I can say this is the question for repeat telecast of previous question. But again, it's a strong recommendation for everyone. There's two questions here. Do number of questions. Questions will help you to, I can say, build up your concept, right? So have a look questions. I'll solve these questions one by one, right? So what we can find speed. First, we can find out this right this equation as it is. So y is equals to 0.035 meter sine bachar battery 10 pi t minus 3 pi x plus 5 by 4. Now let's get battery. So t and x both has a different sign. So what's the motion of particle? Positive x-axis is there. So you need to put a right answer here. Motion of particle positive x direction. What, my dear? Motion of particle is what? Positive x direction. Okay. Then Metaji. This is we have to find what velocity of wave. Simple, yeah. I just see it in the class. You can say part A. In part A, I guess I'm calling Roman in Roman part 1 and part 2. Velocity of wave which I give in the classroom, yeah, it's a short trick. In the classroom, Metaji, in the classroom, student, I gave you short trick for velocity of wave. Always keep in your mind. What, my dear? Coefficient of what, student? This is coefficient of time upon beta z, coefficient of x, coefficient of time upon beta, what we can say? Coefficient of x, right now. So what is coefficient of time, bacha? 10 pi here. So right away, party. No need to worry about minus n because already have taken mod. So this is what, my dear? 10 pi, and this is 3 pi here. Cancel. So what will you get? Velocity of wave, which is equals to, my dear, 10 by 3 meter per second. Velocity of wave, my dear, what you can say? 10 by 3 meter per second. 10 by 3 meter per second. I hope you got it. Okay. Beta, which direction here? Because you mentioned direction but semantic. So you can write your answer beta in a like sequence or systematic way. This is 10 by 3 I cap meter per second. Yes. Yes, my dear. You can write it up. This is the velocity of particle here. Wave velocity. What, my dear? This is 10 by 3 I cap meter per second. 10 by 3 I cap meter per second, my dear. Okay, fine. Now, next year. Now, next year. Okay. Beta, what you do? Part 1, beta, I finished it. Part B, what is the vertical positions of the of an element of the string at t0 x is equal to 0.1 meter. Okay, now beta, I'm going to solve beta. Part number B. We have to find vertical distance here. What beta? We have to find vertical position of an element. That is, you need to write beta. What's the component? Mention the question information. T0 beta g and x is equals to 0.1 meter. At this point here, we have to find what? Vertical positions. At what beta? Vertical position here. So beta, have a look here for these questions. Just again beta, write questions number one. Which is mentioned in the questions. What is the 0.0? Sorry, 0.35 only here. I here also wrongly. 0.0335 I have taken. Equal to 0.35 only beta. Yes, beta, 0.35. And so what might be 0.35 students? This is sine what by dear 10 pi t minus 3 pi x plus pi by 4 beta. Once you think this is correct now. 0.035 beta sine 10 pi t minus 3 pi x plus pi. Correct, my dear. Very good. So beta, have a look at here only. So you can feed beta t0 and x0. Both are 0, 0. Both are 0, 0 right here. Okay. So here beta, what you can see for this condition here, x is what? 0.1 meter. So y is equals to beta 0.35 sin बच्चा 10 pi t x. It's 0 बच्चा party minus what beta you can say? This is 3 pi into x. 3 pi into x. Now बच्चा x beta what we can say? 0.1 here. So this is you can it's meter here. Right beta in centimeter here. So this is 0. Beta you can say 3 pi meter beta only here. Into beta plus you can say pi by 4 plus beta what we can say pi by 4. Okay, so just do here it's normal. I can say simplification further, my dear. So y is equals to 0.35 sin बचा party minus 0.35 1 by 4 beta 0.25 na 1 by 4 beta what is 0.25 here. So plus you can say beta 0.25 pi 0.25 pi. Okay, so this much here point pi beta remains common. There is no doubt. So just solve further by party. You can say y is equals to beta 0.35 sine of beta. 0. This is what 0.05 0.05 into pi bacha. So we'll get what minus I'll use here. Uh, okay. So now bacha, you can see bacha, this is what sine bacha party. 0.157 157, right? Yes beta, I'll take class here and beta and I'll predict questions for tomorrow test. I'll take classes today and also I'll predict questions. I'll take your class around 9:15. Yes, I'll take your class around 9:15. I'll take your class 100% beta. Yeah, y is equal to what? 0.35 sine y beta minus 0.157. 0. Beta what is 157 here. Further, just feed the value beta party, you will get here. Y is equal to what, my dear? This is 0.35 in meter. Meter this one here will get negative here. Minus beta 156. Just further solve beta party, you will get here minus 5.48 centimeter. Minus what, my dear? 5.48 centimeter. Okay. Now it's a party. Next year, that is option number C. What you have to find number C? What is the wavelength and frequency? I'll repeatedly asked. So beta for wavelength here, what you can write, my dear? What you can write, my dear? For wavelength here, this is what you can say beta 2 pi by k, 2 pi by k here. So this is beta g 2 pi and k beta how much? 3 pi beta. K beta what we can say? This is what 3 pi, 3 pi beta. This is radian. This is what I'm cancel here. So this is 3 pi here. 2 by 3. 2 by 3 beta, I can say 0.667 meter. So beta your wavelength 0.667 meter. Beta what you can say 0.667 meter, right? Okay, fine. Bacha party. And beta also we have to find in part number C bacha frequency. This is what frequency bacha. So what you can say this is omega upon 2 pi. Omega beta what's meant in the question also? Omega bacha ji. What is this omega? This is 10 pi bacha. You can write my dear. Omega is what? 10 pi upon 2 pi. Cancel. So what you can say bacha? Frequency is equals to 5 hertz. This is what my dear frequency is equals to 5 hertz. Okay, fine. Bit after this here. That is, I can see it options number D. Last bit option, but I can see these questions. What is the maximum transverse speed of the element? Okay, we have to find the maximum transverse speed of the element, right? So it's a differentiate here given equations. So what is the equation with the party? Y is equals to 0 point beta 35 sine of beta. Keep in mind here, it's SI unit. Sine of beta 10 pi x minus beta z 3 pi g plus student pi by 4 plus student what you can say this is the pi by 4. Simple bacha. Okay, so as I said multiple times, you can apply concept of what? Partial differentiation. Yes, student at the same time, if we have a two variable in any equations, so you can keep one is constant, differentiate another one. So here student, I'm going to differentiate with respect to time, keeping x constant, keeping x constant. So I'll get here velocity of particle. That is what dabba by dabba t. So this is what my dear 0.35 here. So again you can apply same rule my dear. Sine what you can say bacha cos. This will become as it is here. 10 pi x minus 3 pi t plus it is the pi by 4. Just multiply bacha coefficient of time bacha only. So this is what my dear 3 pi here. So you can just see bacha 35 into 3 beta. What we can say 105. What you can say bacha part this is what 105 here. So simply bacha I can find velocity of particle. Beta this is what you can say minus 0.35 into 3 pi cos beta z 10 pi x minus 3 pi t plus beta pi by 4 plus beta what you can say this is what beta g pi by 4. This is what my dear you can say pi by 4 right now. If this is a pi by 4 beta, so further yeah, you can see beta this thing already I see beta multiple times because this is what my dear cos can varies. Cos can or you can say range of cos plus 1 to minus 1 plus 1 to minus 1 plus 1 to beta what you can say minus 1 right. So this is beta velocity of particle here. You can write with this I'll take here minus this entire term students. Student, I'll take care. This entire terms is what minus Vajrapati. So this is minus 0.35 into beta 3 pi beta 1 year. So minus minus plus. So further beta we can solve here these questions. In 3 pi bacha. Do we are by this I can say this is 1.05 1.05 into beta pi 50 care 3.14. Further solve here So we'll get 1.11.0 meter per second. So this is what my dear is maximum velocity of particle. Maximum velocity of particle. Okay, let's do better. Next question, yeah. That is, I can say last question to the class. Yes, sir. So next question is, yes, beta. This is the last question for the class, my dear. Okay. So again, beta, I'm taking your data randomly. Y is equals to 0.03 sine of 3x minus 2t. What, my dear? Y is equals to 0.03. Listen that this is 0.03 sine of 3x minus 2t. From here, what you can predict? Sir, wave motion is what? Positive x-axis. Wave motion is what? Positive x-axis. Okay, so let's just do the question here further. Few questions are left for yourself. You can do at home. Few questions I'll do only. So this question I'm going to leave to a chair. Let us suppose we can take a chair time zero. Find displacement. Find displacement at beta x. You can take 1 times 0. X beta you can take 1.1 meter, and beta you can take here x 1 time 0.2, and last beta x you can take 0.3 meter. That's it. Yes, that's it. This is students your homework. You can do at home. You can do at home with these questions. Okay, fine. In Vivacha, I can say this last questions. You can. I'll ask you that one easy questions. Find velocity of particle. Find velocity of oscillation of particle in the string. Right, with a particle. So you have to find velocity of particle in oscillation of the string here. So in part Vivacha, find velocity of particle in the string. Find what, my dear? Velocity of particle in the string here. Right. Okay. So I'll do this question only. Remaining bit I'll leave here for your home. You can try. So I hope you remember here. Velocity of particle. How can we find? That's simple. Just given equations. Let us suppose this is equation number one. You have to just differentiate one time with respect to time idea. So you can see what here. This is basically dabba by dabba t. Beta just differentiate these above equations, keeping x constant by there. So this is, you can say, 0.03 sine beta cos. So this is 3x minus 2t. Beta, what we can say? This is the minus 2. This is the minus 2. So we can write here finally. Velocity of particle is what? Minus 0.06 into cos beta 3x minus 2. 3x beta, what we can say? Minus 2t. Right. So I can say what I just gave few, I can say the assignment only one question, and remaining question here I already solved all the questions. Just revise the formula, write formula more than time, more than one time. Practice more. That is a, I can say, with a major thing. I can say those students going to write a 12th class exam, do practice more. Or I can say anyone will go to write like with your 10th class exam. So practice with highly required. So for practice more students, right? So this is all about with I can say 11th class session. I'll start 12th class session around 9:15 or 20. Now, student, I'm going to start your session. All the very best.